Good morning, everyone. This is Shekhar Tyagi, Assistant Professor, Department of CSE. Welcomes you all in a new series of new session of IIC activity under the heading different TRL levels of a prototype. And today we have a very eminent guest with us, Ms. Akansha Rajput, who is a software developer with Apwas Technologies Private Limited, Noida. She is undergoing a doctoral degree in embedded systems and having an experience of around three years in research and development related to embedded systems. In today's session, she will be basically demonstrating with an IoT and machine learning type of case scenarios that what are the different TRL levels that are basically known as technical readiness levels. T1 to T9, we define basically these types of levels, and why they are basically used and what are their implementations and what are their demonstration as far as prototyping development is concerned. So, without wasting much of the time, I will request Ms. Akansha Rajput to please have the mic and deliver the session. Ma'am, please.
Thank you, sir. I hope I'm audible to everyone.
Yes, ma'am, you are audible.
Yeah, so let's just discuss about different TRL levels that we have. So basically, first one we have that is basics principle of observed and reported. So in which I'm gonna discuss about the hardware description, software description, and exist criteria. So let's just start with hardware description. So scientific knowledge generated underpinning hardware technology concepts application. If I'm talking about software description, so scientific knowledge generated underpinning basic properties of software architecture and mathematical formulas. If I'm talking about existing criteria, so pre-reviewed publication of research underlying the proposed concept applications. Second one that we have that is technology technology concept and application formulated. If I'm talking about the hardware description, so invention begins, practical application is identified, but is spatially not no experimental proof or detailed analysis available to the support to the conjunctions principle. If I'm talking about the software description that we have, practical application is identified, but is respectively not experimental proof or detailed analysis is available to support the conjecture, basic properties of algorithm representation and concepts definition, basic principles coded descriptions of the application concept um, that the address flexibilities and benefits. The third one that we have that is analytic and experimental criteria, critical functions and characteristics proof of concepts. The hardware description that we have that is analytic studies place the technology in an appropriate context, and the laboratory demonstration, modeling and simulation valid and analytic predictions. If I'm talking about software description that we have that is development of limited functionality to validate critical properties, prediction using non-integrated software components. The existing criteria that we have that is documented analytic experiment results validating prediction of key parameters. The fourth one that we have that is component and breadboard validation in laboratory environment. The hardware description that we have are low fidelity system components. Breadboard is built and operated to demonstrate basic functionality and critical test environment and associated performance predictions and defined relative to the final operating environment. If I'm talking about software description that we have that is key functionality critical software component are integrated and functionality validated to establish interoperability, and being architecture development. Relevant environments defined and performance in this environment predicted. If I'm talking about exist criteria that we have, that is documented test performance demonstrating agreement with analytic prediction, documented definitions of relevant environment. The fifth one that we have, that is component and breadboard validation in relevant environment. The hardware description that we have, that is a medium fidelity system, component brass, um, component brass board is built and operated to demonstrate overall performance in a simulation operational environment with the realistic support elements that demonstrated overall performance in critical areas. Performance predictions are made for subsequent development phases. If I'm talking about software description, end-to-end software elements implemented and interfaced with existing system simulation, conforming to target environment, end-to-end software system tested in relevant environment, meeting prediction performance, operational environment performance predicted, prototype implementation developed it. If I'm talking about exist criteria that we have, that is documented test performance demonstrating agreement with analytic predictions, documented definition of scaling requirement. These fives are the TRL that we have. Apart from that, we have four more. I hope my screen is visible. Please let me know that the screen is visible or not. Okay, so the sixth one that we have, that is system, subsystem model or prototype demonstration in operational environment. If I'm talking about the hardware description that we have, the a fidelity system component prototype that accurately addresses all critical scaling issues is built and operated in relevant environment to demonstrate operation under critical environmental condition. If I'm talking about software description that we have, that is prototype implementation of the software demonstrating on full scale realistic problem, partially integrated with existing hardware software system, limited documentations available, engineering engineering flexibility full demonstrated. If I'm talking about exist criteria that we have, that is documented test performance demonstrating agreement with analytic predictions. If I'm talking about system prototype demonstration in an operational environment, if I'm talking about the hardware description, that is high fidelity engineering unit that accurately addressed all critical scaling issues is built and operated in a relevant environment to demonstrate performance in the actual operational environment, and platforms are ground, airborne, and or space. If I'm talking about software description that we have, that is prototype software are exist having all the key functionality available for demonstration and test. Um, that is integrated with the operational hardware softwares system demonstrating operational flexibility. Most software bugs removed, limited documentations available. If I'm talking about exist criteria that we have, that is documented test performance demonstrating agreement with analytic prediction. The eighth one that we have, that is actual system completed and high qualified through testing and demonstrate. If I'm talking about hardware description that we have, that is the final product in its final configuration is successfully demonstrated through test and analytic for its intended operational environment and platforms. For example, that is ground, airborne, or space. If I'm talking about software description, that we have all softwares has been truly debugged and fully integrated with all operational hardware and software system. All user documentation, training documentation, maintenance documentation completed. All all functionality successfully demonstrated in simulation operational scenarios. Verification validity completed. If I'm talking about existed criteria that we have, that is documented test performance, verifying analytic prediction. The last one that we have, that is actual system flight proof through successful mission operation. The hardware description that we have, the final product successfully operated in actual mission. If I'm talking about software description that we have, that is all software has been truly debugged and fully integrated with all operational hardware software system. All documentations has been completed. Software engineering supported in a play system that has been successfully operated in operational environment. If I'm talking about existed criteria that we have, that is documented mission operational results. These all different RTL levels that we have. I hope, am I clear with all of you? Okay, so let's just move on our um, our topic, that is introduction to the internet. If I'm talking about IoT, so IoT stands for Internet of Things. Okay, so let's just discuss about internet first. So what is internet? If I'm talking about the internet, so internet is the basically a network in which we have connected multiple devices together, and over the signal we can transmit our data and we can receive our data on the real time. Okay, so basically in the internet we have to work on the real time data. Okay, we can get our real time data, we can transmit our real time data, or we can basically we can communicate our real time data. Okay, so if I'm talking about internet, so internet we can access through multiple electronic devices. The most commonly electronic devices used to access the internet, that is tablet, that is another one is your mobile phone, and the last one that we have, that is computer. Because if I'm talking about the user perspective, so these three are the most flexible electronic devices to access our internet. So basically when we turn on the internet, suppose that if I have a mobile phone and I'm just connected to the internet, so I have two options. I have a cellular data, simply we can say our mobile data. If I'm talking about in technical terms, so we have call it cellular data. Okay, other second one that we have, that is wireless connectivity. Commonly it is known as Wi-Fi. Okay, we have routers in our home, we have routers in our college and the different fields. Okay, so we have these two options to connect or to access the internet. So let's just suppose that I'm using my mobile phone and I've turned on my cellular data. So basically by turning on the cellular data or by connecting to any Wi-Fi network, so basically we have connected to the servers. Okay, we have the servers. So we have various multiple servers. For an example, if I'm talking about shoppings, so to do online shoppings, we have various servers. For an example, we have Amazon, we have Flipkart, or we have Misho, we have Mintra, we have Nika. So we have different kind of servers. So by turning on the internet, by connecting to the internet, basically we can access our different. We have connected to the different servers, and we can take the information from the different servers. There is a no rule that at a time you can access only one server. There is no rule. So basically if I'm talking about internet, so over the internet we can connect it to multiple servers. We can connect to the multiple shopping servers, as well as we can connect to multiple banking servers. At a time we can check our e-passbook. Let's just suppose that you swap up ATM, and let's just suppose that you withdraw a cash from the ATM. Okay, after withdrawing the cash, you can check to your e-passbook that the transaction has been uploaded to your e-passbook. Because if I'm talking about IoT, so in the IoT the real time data is uploaded within 2 seconds to the server. So it will hardly take 2 seconds. So when you do any transaction, when you transmit any data and when you receive any data, so it will take only 2 seconds to upload or to refresh the data. Okay, apart from that, we have the music system. We have heard a lot of online musics. We have many applications. We have, for an example, that we have, that is YouTube, we have Netflix, or we have Spotify, we have Geo7. We have various kinds of multiple servers to listen this song online. Another one example is your mail. We have used Google, right? So Google is basically, Google gives a multiple application to the user that is completely free of cost. We can use Drive, we can use mail, we can use Google Photos, we can share real time Google Sheets, Google Documents. So various kind of application Google gives to the user, and that is completely open source, means you don't need to pay any charges regarding that. So basically, by turning on the internet or by connecting to the internet, we can access different servers. We can take the information from the different servers. The last one that we have, the collaboration. So right now we are connecting, right? We have we have organized the webinar. We have like, so in this platform, basically the multiple peoples are connected, right? Me, you, and your teachers will connected on the internet. So the main communication medium, that is the internet, and the platform that we are using, that is Zoom. So with the help of internet, we can collaborate, we can collaborate with the multiple peoples on the real time. We can send our real time data, we can receive our real time data. So in the IoT, we have to focus only two things. One is the internet, and another one is the real time data. I hope, am I clear with the internet? So if you have any questions or if you have any doubts, so you can ask in the middle of sessions or at the end of the session, as well as you can write down in the chat box that if you have any questions regarding that. Okay, so basically, if I'm talking about internet in simple terms, so internet is a signal in which we can connect multiple devices, and the multiple devices can access the multiple servers information, as well as we can send the information real time and we can receive the real time data. Okay, so this is all about internet, but in the IoT, one more thing that we have, that is things. So let's just discuss about things. We have multiple things, right? Right now we have multiple things surrounding us, that is our desk, chair, AC is there, light is there, mobile phone is there, laptop is there. So we have multiple things around us. But if I'm talking about things that is considered in IoT, so for an example, that suppose that we have a water bottle. So can I give the internet to the water bottle? Can I give internet to the desk? Can I give the internet connectivity to the chair? So basically, in the IoT, we have to consider electronic things. Okay, we have to just focus on the electronic things. Let me show you something. Let me show you that we have in my hand. I hope it is visible to everyone. Please see in the camera. So this is the Arduino Uno Development Pro. So basically, this is our development board that we have to use in IoT to control multiple peripheral devices. If I'm talking about the peripheral devices, so we have some input devices or we have some output devices, right? So if I'm talking about the output devices, so in the case of output, I have this LED. I hope it is visible to everyone. So if I want to control this, I want to control this light. So for that, I have to connect with it the development board. Okay, I cannot control this directly. Okay, to control this light by some instruction, by some programming language, so I have to use this development board. This development board plays a very important role to control any electronic devices. If you want to control your AC, you want to control your television, you want to control your refrigerator, anything that you want to control, in that case you have to use this Arduino board, because on the Arduino board we have this black one. I hope it is visible. This black one, is known as the microcontroller. Okay, it's in a simple terms you can say IC. Chips are the alternative name, but if I'm talking about in a technical term, so it is called microcontroller. Okay, let's just discuss about the micro. Micro means small. Controller means controls a particular thing that control multiple peripheral devices. Okay, now if I'm combine these two words, the microcontroller, so it's the same that we have a small IC that control various performance, that we controls various function, that controls various input output devices. So the microcontroller plays very important role to work in IoT. Okay, apart from that, we have some input and output ports, this black one here, this black one here, and the black one here. It is known as ports. So we have two ports over in the board. First one is the digital. So it is known as digital ports, where you connect your digital devices. Digital means 1 and 0. If suppose that I have this LED, I want to glow this LED, so I have to give 1. If I want to off this LED, I have to give 0. So 1 and 0 are the digital terms. So if you want to connect any digital devices, in that case, you have to use this digital ports. Apart from that, we have some input ports here. Input means in the case of electronics, we have the sensors. Sensors are the input devices in IoT or in the embedded system. So we have to focus only sensors. Let me show you one more sensor that we have. So I hope it is visible. So this is known as IR sensor. It is used to detect our object. Okay. I'm sure you have seen a lift. Okay, you have seen automatic door system in malls or in restaurants, in hotels. When the person is coming, the gates will be automatically open. When the person will be passed through, the gates will be automatically closed. So in this case, we have to use this IR sensors. So sensors are the input devices in the case of electronics. So to connect any sensor, we have to use some input pins. So we have the input pins over here. Apart from that, we have some power pins. So here is the power pins. Power pins is used to give power to the another electronic component. Let's just suppose that you wants to give power to this IR sensor. In that case, you have to give some ground pins. You have to give some power pins to this. So in that case, you have to use power pins. So these are some input and output devices if I'm talking about things in IoT. So let's just suppose that if you want to let's just suppose that if you want to check the real-time data in your car. So if I'm talking about the car, so car is completely a mechanical plus electronic a kind of device. Okay, so in the real time, you can check the speed, you can check the location, you can check your fuel. So all these parameters you can access to your mobile phone. Okay, and these parameters are completely real time. So in that case, what you have to do, you have to just make a application, and you have to make a we can say that we have to make a internet connectivity in the car. Okay, let's just suppose that you can turn on your cellular data, and you can create your personal hotspot. Okay, the second one, you can use a dongle. The last one, you can use a simply router over there. Okay, so basically the first thing is that you have to create a internet connectivity in the car, and after that you have to connect your web application, or you have to connect your mobile application to the particular wireless network, and after that you will get all the parameters of your car in your mobile phone. So this is completely a real-time data. If I'm talking about this smartwatch, in this case, in the real world, we have to use a lot of smart things. So every smart device is considered in IoT. So if I'm talking about the smart watches, so basically the smart watches are manufactured by two types. One is the Bluetooth based, another one is the Wi-Fi based. If I'm talking about a Bluetooth based smartwatch, so there is a certain range. Okay, we have the certain range limit. So you have to be in the range if you want to get the notification and get all these things on your mobile phone. In that case, you have to be in the particular range. If you are in suppose that your mobile phone is not in the particular range, In that case, you are not able to get all the notifications, all these things in your mobile phone. So what you have to do, you have to be in the limit. So this is a drawback if I'm talking about Bluetooth based watches. So this is the drawback. But let's just suppose this, that we have the Wi-Fi based smartwatch. Okay, so the Wi-Fi based smartwatches, in that case, we have not limited criteria, right? We can send our data, we can receive our data with wide range. Okay, we have no limitations, we have no basically we can say we have no range of limitations. Okay, we can send our data and we can receive our data um, on the very large scale. So a lot of that, we have the Apple watches we have, and the Apple is manufactured by Apple is manufacturing Wi-Fi based e-watches, and many more companies are manufacture Wi-Fi based e-watches. So suppose that I have the Wi-Fi based e-watches, but there's in one rule: the particular watch should be connected with Wi-Fi, and your mobile phone should connect with any internet network. And after, in both the things, suppose that this is my watch and this is my mobile phone. Okay, so when these two devices connected to the internet, then and then only you can get all the notification, all the health monitoring system in your smartwatch. If let's just suppose that your mobile phone is not connected to the internet, in that case the communication cannot be built. Okay, you cannot take any real-time data. So there's one rule in IoT: if you want to transmit the data, if you want to receive the data from any device, there is one rule: the device should be connected with the internet only. Okay, you can create your cellular data, or you can use your any Wi-Fi network, but there's a rule, you have to fulfill this rule, then and then only you can work with IoT. Okay, if I'm talking about smart home, so to make the home as a smart home, we have a lot of electronic devices in our home. We have light, we have AC, we have a microwave, we have a washing machine, a lot of electronic devices we have. Okay, so what we have to do, we have to make our internet connections. Okay, we have to make a network, and that particular network you have to connect with your multiple electronic devices. Okay, you can connect your television, you can connect your light, or any another electronic device. You have to connect it to be in a particular network, and in that particular network you have to apply a Wi-Fi network. That's it. In this case, what we have to consider, your internet connectivity should be continuous provide by the particular electronic device. Okay, suppose that I have 5 different electronic components. Suppose I have the light, I have microwave, I have television, I have washing machine, and I have fridge. So what we have to do, we have to make a network, and all the different electronic device we have to connect with the network, and after that we have to give the internet connectivity. That's all. And for that, what you have to do, after connecting different electronic components in a particular network or in a particular Wi-Fi network, okay, now second thing we have to consider to getting our data. Okay, to access the data, suppose we want to control the light. Suppose if I'm saying that turn on, light gets turned on. If I'm saying that turn off, the light will be gets turned off. So in that case, these data, that is turn on and turn off, these particular data we have to collect. So in that case, what we can use, we have various IoT servers. Okay, as I told you that when we're turning on the internet, we have connected multiple servers. So in the case of IoT, we have various different kind of servers that is completely open source. The first one is the Blink, BLYNK. Blink is the completely open source servers in IoT. After that, we have Adafruit, we have IFTTT, okay, we have ThingSpeak. So these are few completely open source servers that is provided by the IoT, provided by the Internet of Things. So you can use any platform and it is completely open source. You don't need to pay anything regarding that. As well as you will get your real-time data on these particular servers. Okay, so what you now you can create one more thing. You can create your own personal app. You can create a particular mobile application. Okay, and it is completely your personal. So what you have to do, you can create a light icon. Let me show you something that I have created. Okay, so see in the camera, I am using this server, and this server is known as the Blink server. Okay, and in this Blink server, it is just look like a mobile application. You can go to your Play Store and you can simply write down Blink, BLYNK. Then you have to install an application that is Blink Legacy. Okay, so here we have few options that we have connect various electronic components. We have to just drag and drop the things. Okay, so I have created a button over here. This is my button. I hope it is visible in the camera. So this is my button. Okay, I have created this button. Okay, so basically through this button, I can control any electronic device. Okay, I can control any home appliance. I can control the light. I can control the AC. I can control the smart television. So in that case, what you have to do, you have to focus one thing. You have to get some data. In that case, you can create your own personal IP address. Okay, and that particular IP address, you can control various electronic components. Okay, so it is completely up to you that you can use a simply mobile application. You can create your personal application. You can create any IP address. Okay, so for why we have to use these kinds of things? Because if I'm talking about GUI, that is your graphical user interface. Okay, so these all plays basically a graphical user interface role. In that case, you can get your data. You can save your data. Okay, so that's why we have to use any kind of any the servers. Okay, if you are not using any server, so in that case you are not able to connect, or you are not able to collect the data. Okay, so collect the data, to manipulate the data, or to control the different devices, you have to use our servers. Okay, so with the help of like a Blink server, with the help of ThinkSpeak, with the help of Adafruit, IFTTT, you can make your home as a smart home. After that, we have that is factory. If I'm talking about a factory, so in the factory we have different kind of machines. Okay, and we have different kinds of robots. So let's just suppose that I have 5 different machines. So if I'm talking about a human being, so being a human being, we are lazy, right? We are not able to go to the particular machines and collect the information and then analyze it and then use it. Okay, it is quite complicated. So what we can use, we can do one more thing. We can create a robot. We can make a robot, and that particular robot will be work on the particular machine, and after that the robot will give you the real time data. Okay, and the particular data will be uploaded on your server, or the particular data will be uploaded on your mobile application, and after that you can analyze your data, you can manipulate it, and you can use it easily. So this is make your task very easy, very smooth, and effortless. Right, being a human being, but we have to consider, we don't need to put a lot of efforts. Okay, so with the help of internet, with the help of IoT, you can create, or you can use these kinds of applications. I hope, am I clear with IoT? So if I'm talking about things or different kind of devices, or a technical definition regarding IoT that we have, that is taking everyday things. Let's just suppose that we have different kind of electronic devices. We have sensors, we have some softwares. So basically embedding them with the electronic devices with some software, sensors, and then connecting them to the internet, and enabling them to the collect or exchange the data without human interaction. It is called Internet of Things. So let me give you one more example. So I hope you can see the sensors. So basically this is the plant. Okay, and this plant, I have connected one thing, that is our soil sensor. Okay, this is soil moisture sensor. If I'm talking about sensors, so basically sensors are the input devices in IoT. If you want to get the real-time data through the environment, okay, let's just suppose that I wants to collect the temperature and humidity current in the room. Okay, I want to collect the real-time data. I want to check the temperature or the humidity in this room. In that case I have to use sensors, because sensor is the only thing that by the sensor you can get the real-time data. So this is used to soil moisture sensor. So the soil moisture sensor will give you the moisture of the soil, and that is completely real time. Okay, and after getting the data from the sensor, the particular data will be sent this signal to the control center, and after that the control center sends this command to the sprinkle. So here we have this sprinkle. Okay, so basically the first one, we are getting the data, we can upload the data. Okay, we have to analyze the data, and after that analyzing, the particular device, the particular control system will trigger your output or input device. So in this case, sprinkle is the output device. So let's just suppose that I have considered two things. One is the dry level and another one is the hydrated level. So if the soil moisture sensor getting the dry level in the soil, so what we have to do, we have to just turn on the sprinkle. Okay, and it is completely automatic. You don't need to go and you don't need to go and switch on the sprinkle. No, nothing. It is completely automatic. Okay, so when the soil is at dry level, the sprinkle will be turned on automatically. When the soil is at hydrated level, so the sprinkle will be turned off automatically. There is no need to any human intervention. So it is called IoT. So you can consider it as smart irrigation system. So this is the small example. You can perform it on the large scale. Okay, so we have a lot of IoT devices surrounding us. Let's just suppose we have smart televisions. Okay, there is no need to there is no need to control a television by the remote. You can control the smart television by your voice as well. For an example, turn on the particular TV system will be turned on. If you set turn off, the particular TV system will be turned off. If you want to change your channel, so let's just suppose I want to change my channel. Simply, I have to just send it a one instruction, that is change my channel to this, and the particular smart television will be change our channel. If I'm talking about the smartwatches, we have smart homes, we have the Google Assistant, we have Siri, we have Alexa. So these are completely IoT devices surrounding us. Okay, so if I'm talking about components of IoT, so we have four important components in IoT. The first one is the sensors, because if you want to get some data, in that case, you have to use sensors. So sensors plays a very, very important role in IoT. Let me show you one more sensor that I have. See, in the camera, I have this light sensor. Okay, so it is known as light sensor, or simply we can set it LDR. So if I want to control or if I want to make any light related device, okay, let's just suppose that if I'm coming in the room, the light will be turned off. If I leave the room, the lights will be turned off. Okay, so in that case, I can use this LDR, I can use this light sensor. Okay, so that's why I told you that sensors plays a very important role in IoT. After that, connectivity. Okay, the particular device should be connected with the internet. Okay, and the last one, your servers, your IP address, your mobile phone, or any kind of mobile application. That particular thing also connected with the internet. So connectivity is the second most important parameter in IoT. And after that, that is our data processing. So in that case, you can use any microcontroller, or you can use any microprocessors to execute your instruction, to analyze your data, and to process your data. After that, user interface, the fourth important application, that is your user interface. So in that case, you can use any IoT server as well as you can create your own IP address, you can create your own personal apps. So these four are the main important concept and main important component of IoT. Okay, let's just suppose that I have the device, and the particular device we have to connect with the cloud. And after that, with the help of any application, we can trigger this particular device. Okay, let me show you one more thing. Let's just consider one thing. Okay, I have this Arduino board in my hand. Okay, so if I want to give internet to this Arduino, so there is no on system Wi-Fi module in this board. Okay, Wi-Fi modules plays a very important role in any kind of development board. Okay, so if I'm talking about this Arduino board, so in this Arduino board, I don't have any kind of Wi-Fi module. Okay, so what I have to do? I have to connect the Wi-Fi module externally. Okay, I have to connect the Wi-Fi module externally, and putting one more electronic board with this board, it will be make a complex system. Let's just suppose that I have the Wi-Fi module. Okay, suppose that I have this Wi-Fi module. Okay, so what we have to do, we have to use a lot of electronic connecting wires. Okay, and suppose here I have only 3 wires. Okay, so what I have to do, I have to connect these 3 wires to the board. First of all, I have to check the wires as well. Let's just suppose if one of the wire will be faulted. In that case, you are not able to send the data. You are not able to receive the data. So very first step is that we have to check our connecting wires. After that, we have to make our connections. Okay. And it will be make a more complex system. Okay. So we have one more option. We can use this board. Okay, this is known as node MCU. Okay, instead of Arduino and instead of connecting one more device with the Arduino, we can simply use this node MCU. Okay, this is known as node MCU development board. So in this board, I have on system SoC. SoC means system on chip. Okay, we have this SoC and it is known as Wi-Fi module. Okay, this is our Wi-Fi module, and the Wi-Fi module name is ESP8266. This is our Wi-Fi module. So I don't need to make one more connection. I don't need to make any complex kind of system. Being an engineer, we have to focus one thing, that is we have to make our device with less complexity. Okay, so in this case, I don't need to connect it externally. It is completely on system. As well as I have some pins over here. Let me remove this and let me show you. Okay, so I have a lot of pins here. So these are some input and output pins. Okay, where we connect any input device or where we connect any output device. Okay, and we have this micro USB cable over here. Okay, this is simply micro USB cable. And let me show you the cable as well. So in my hand, here is the cable. Okay, here is the cable. So by using this cable, what we have to do, we have to just connect this like that. Okay, it is connected. The second point, this A-type USB, we have to connect with the system. Okay, after that, on this system, I have one more thing. This is known as antenna. It is on system antenna. Let's just suppose if I'm talking about a mobile phone or if I'm talking about a laptop. So in the laptop or in the mobile phone, we have these kinds of antenna. It is called as on system antenna. Okay, you can simply say SoC antenna. Okay, so this antenna plays very important role if I'm talking about the Wi-Fi connectivity or wireless communication. Okay, if you want to do wireless communication between two devices, so you have to use this antenna because the antenna is used to create a wireless connectivity. If I'm talking about a router, so in our home, the router is the device that create a wireless connectivity, and the antenna
is used to create a wireless network on some particular frequency. Okay, let's just suppose that if your antenna is bricked, so in that case you have to replace your router. So that's why where you have to use wireless communication. So in the wireless communication, you have to use these kinds of antenna. So use this use this Arduino. I can simply replace this Arduino by this node MCU. Okay, because in this case, I have to connect the external ESP module. I have to connect a lot of wires. So it will be more complex if I'm talking about this node MCU. If I'm comparing this Arduino with the node MCU, so in the node MCU, I have this on system Wi-Fi module. I have simply write some instruction for that, and after writing the instruction, the particular device will be connected to the internet. So this is why in case of IoT, we can use this node MCU, and apart from this node MCU, we can use our Arduino as well. So it is completely up to us, because hardware devices we have to choose as per our requirements only. So in these sessions, I'm going to use this node MCU only. And with the help of node MCU, I'm going to control this light. Okay, I hope am I clear to all of you? Okay, so let's just discuss about some programming language. Okay, so if I'm talking about industry, so in the industry, we have a lot of programming languages. Let me share my whole screen. I hope you guys are able to see my screen. Okay, so if I'm talking about a programming language, so in industry, we have a lot of programming language. We have C, we have C++, we have Java, we have HTML, we have CSS, we have Python. A lot of programming languages we have. But if I'm talking about IoT, or if I'm talking about to control any electronic component, okay, if you want to control any electronic component or device, so you have to choose the language as per your hardware. Okay, you cannot choose any kind of languages. No, as per your hardware, you have to choose the language. If I'm talking about this Arduino, so in the Arduino, we can program by using C, C++, or Java. Okay, if I'm talking about node MCU, so in the node MCU, you can use C, C++, HTML, or you can use MicroPython. Okay, so these are few languages that we have to use. So as I told you, according to the hardware, okay, according to the hardware, we have to choose our language. Okay, so in this case, we are going to use node MCU. So in the node MCU, we are going to write some instructions with the help of C, C++, HTML, and the MicroPython. Okay, and if I'm talking about IoT servers, so we have few servers. For an example, we have Blink, we have IFTTT, we have Adafruit, and we have ThinkSpeaks. Okay, these are few servers that is given by IoT, and it is completely open source. So you can choose anyone. So in this case, I'm gonna use the Blink server, as well as I'm gonna create a personal IP address. Okay, by using HTTP protocol. Okay, we have some protocols to communicate with any devices. You have to consider with the protocols. Okay, right now, am I communicating with you? Right, so I have some protocols. Similarly, if you want to transmit your data, or if you want to receive your data, So in this case, you have to use a protocol. Okay, so we have various protocol. We have HTTP, we have HTTPS, we have MQTT, and many more. So in this practical, firstly, I will use the Blink application, and after that, I'm gonna create a personal IP address by using HTTP. Okay. So let me show you some electronic components that I have with me. So basically, okay, so I have this light sensor. I have this fire sensor. Uh, I have this IR sensor. So basically, if I'm talking about these things, so these are completely, they all are the sensors. Okay. So, and one more device that we have, that is output, that is your LED. So LED stands for light emitting diode. The LED has 2 points. One is the positive point, another one is the negative point. And I'm going to use this node MCU to control this LED. Okay, so let me share my screen and let's just start doing that practical. So I hope that you are guys able to see my screen. Please let me know that the screen is visible or not.
Yes, ma'am, your screen is visible, ma'am.
It is visible, sir?
Yes, ma'am. Yes, ma'am.
Right? Okay.
How much time
So
you have taken right now?
I'm using, it is known as Arduino IDE. Okay. So let me make it little bit zoom so that you guys can see this. Okay. So there is some comments. So I have to just remove these comments. Okay. To control this node MCU, okay, and to upload the code inside this node MCU, I have to use this Arduino IDE. In a simple term, if I'm talking about languages, right? So if you want to work with C, C++, Java, Python, HTML, so in that case, you have to also use some particular IDs. So similarly to the hardware. Okay. So firstly, I have to define some macrons. So I am gonna use this define. As I told you that I'm gonna use a Blink platform, a Blink server. So I have to create a macro that is known as serial. Okay. After that, we are using Wi-Fi module, and the Wi-Fi module name is ESP8266, right? So I have to add a library for that. And to add a library, what we have to do, we have to just write down. We have to just simply write down hash include and our library name, that is ESP8266 Wi-Fi.h. This is very important library. Okay, so I'm gonna comment this. I'm gonna write this, that this is ESP8266 library. After that, we are using Blink server. So I have to connect one more header file for the Blink server. So I have to just simply write, that is Blink simple ESP8266.h. These three things are very, very important. Okay. After that, we have to give a Wi-Fi name. We have to give our Wi-Fi passwords name, right? So what we have to do for that, we have to create 3 parameters. Okay, we have to create 3 parameters. So what we have to do, we have to just simply create our kind of string, and that is firstly, that is the authentication. Okay, so I will tell you what is this authentication later. And after that, we have to just write our Wi-Fi name. And if I'm talking about in technical terms, so Wi-Fi, it is called SSID. So in the SSID, I have to write my Wi-Fi name. So my Wi-Fi name is IoT. That's all. And it is quite case sensitive. Okay, so you have to write same as per whatever you are writing your Wi-Fi name. You have to write exactly the same thing. After that, we have to give our password. So I'm creating one more string for that. Okay, and I'm just writing the password. So I'm just writing IoT@12345. This is password for my Wi-Fi. Okay, these two parameters are very, very important, and they both are the case sensitive. After that, what we have to do, we have to just starting writing our data. So for that, what we have to do, we have to just write serial dot begin. Okay, so let's just discuss about baud rate, because baud rate performs a very important role to communicating between two or more than two devices. So right now, am I communicating with you? So I have a constant pitch. So this constant pitch is my baud rate. Okay, so or if you want to communicate between two devices, so what we have to do, you have to just set off data. You have to set off a limit. Okay, so baud rate is known as it is defined as the transmitting the number of symbols transmitted per second. Per second kitna data aapka ja raha hai, per second how many characters you are sending, it is called as baud rate. So we have some standard baud rates. So in the case of Node MCU, the baud rate is 115200. This is the standard baud rate. After that, we are using Blink server. So we have to start our Blink server by writing the function that is blink.begin. That's it. So in this function, we have to pass three parameters. First is the authentication key. Second one is the SSID. And the last one is the password. These three parameters are very, very important. Okay, and after that, we have to call one more function in the void loop. Loop means a particular statement that execute again and again. It is called a loop. So if you want to trigger your device multiple times, okay, not only single time, if you want to control the device, if you want to trigger the device multiple times, so in that case, you have to call one function inside this void loop. It just look, the function of void loop is just similar, that is while one. Okay, if you're passing any non-zero value in the while, the particular instruction will be executed again and again. So it's just same that we have in Arduino IDE. So in this function, I have to call one more function, that is
Excuse me, last function, ma'am. Sorry to interrupt you. May I audible, ma'am?
Yeah, yeah, I can hear you.
And how much time you are taking, ma'am?
Sorry?
Ma'am, how much time you are taking to wind up the session?
Sir, I'm not getting you clearly. Your voice is a little bit breaking.
Ma'am,
Can you write down in the chat box?
Yeah, ma'am. Basically, I'm telling you how much time you are taking to wind up the session.
Sir, 5 minutes more. That's all.
Okay. Thank you so much, ma'am. Please continue. Sorry to interrupt you.
It is completely fine. Okay. So so this is our code. Okay, let us discuss about authentication key. As I told you that I'm going to use this Blink server. Okay, so in this Blink server, when you create any any product or any project, so you have to register your mail ID while creating the account on the Blink server. You have to just add your what we can say, your Gmail ID, right? So when you're creating the project on the Blink server, the particular authentication key will be sent it on your mail ID. So give me a second. Let me show you the authentication key that I have. Okay, so let me share. Okay. So in this case, I have created a project and the project name is LED control. Okay, so in this case, I have this authentication key. So what we have to do, we have to just copy this authentication key, Control C. And now what we have to do, we have to paste this in our code. That's all. So let me show you. Okay, so I hope it is visible. So I have already pasted this inside this authentication key. That's all. So basically, this is our small code to control a particular LED. Now, what we have to do, we have to just connect this node MCU. So I am gonna connect this with my system. So it is connected. Okay, and after connecting it, what we have to do, we have to go to the tools. We have to check our board that should selected with node MCU. We have to choose the port as well. These two important parameters you have to check. Okay, that's all. And after that, what we have to do, you have to just upload this. That's all. And it is called compilation steps. Okay, this is our compilation steps. When we are getting done uploading over here, after that we are gonna connect this LED. So we have to wait for a second. Okay, so the code is uploading. Okay, so we are getting done upload. So what we have to do now, we have to just open this serial monitor. Okay, so I guess you are not able to. Let me give you one minute. Let me share my whole screen. Okay, so here we are going to check that the device is connected to the internet or not. So I have connected the LED. Okay, so this is my LED that I've connected with the board. So I have to press this reset button. That's it. Now we have to wait for a second, and we have to check that the node MCU is connected to the Wi-Fi or not. Yes. So it is written that connected to Wi-Fi. We are getting also the IP address, and it is also giving you a command that is connected to Blink Cloud. Okay. So I have the LED in my hand and the application in my another hand. So what we have to do, we have this play button over here. So we have to just play this. Okay. And after playing it, what we have to do, we have to just press this button. So I'm going to press this button, and you can see the lights get turned on. If I'm removing my hand, the light gets turned off. Let me stop share and let me show you so that you can easily see this. So I have this LED and the button. I'm going to press this, light gets turned on. If I'm removing this, light gets turned off. Turn on and turn off. That's all. So one thing I want to mention here, the authentication key plays a very, very important role. If you have the authentication of my project, so in that case, you can control my devices. If I have the authentication key of your project or your hardware device, then I'm able to control your hardware devices. So the authentication plays a very, very important role. So turn it on, turn it off. So the device is also connected to the Wi-Fi, and in my mobile phone, I have connected to the Wi-Fi. So both the devices is connected to the Wi-Fi. And with the help of Blink server, we can trigger the device. That's all. Thank you.
Thank you so much, Akansha ma'am, and you have provided a lot of information about the IoT, and the students learn about and excited about the project and life physics over there. And thank you so much for this session. And in future, hopefully, we are connected for you. Thank you so much, ma'am, Akansha ma'am, and once again, thank you.
Thank you, sir. Bye bye.
Bye.